Hey everybody, Miss Dietrich here. We're going to compare and contrast solving equations versus solving inequalities. So let's just review how to solve an equation. So for number one, they give you m plus 5 equals 6. So we usually rewrite the thing. And then the next step is to apply your inverse operations. So we look for the variable and ask ourselves what's happening to the variable. In this case, we're adding 5 to it. So the opposite of that is to subtract 5. To keep it balanced, we have to do that on both sides of the equation. So all of this cancels out. We bring down the m, and we go ahead and apply the math here. So we're really subtracting 5 from 6, which would be 1. And we bring down the equal sign. Now, how is this different than number 1? The only difference is this symbol. So what we would have to do is just replace the equal sign. We follow the same exact protocol, only we replace it with the symbol that's given here. So they give you this symbol, which is the less than or equal to. Now, what I always recommend when you're solving an inequality is to graph it. And if we graph it, we just make a quick number line. We think about what we got here, which is 1. We think about numbers that might be greater than that, such as 2, 3, etc. We think about numbers that would be less than that, such as 0, -1, etc. Now, in this case, they're talking about looking at some of the numbers in this set and deciding whether or not that's a solution. So in the case of this equation, we know that it's just plain old, this is just m equals 1. That's easy. But when you have an inequality, and you're saying to yourself, m is less than or equal to 1, then we want to find 1 on our number line and pick values that are less than or equal. Now, if we take a look at the choices that they give you in the brackets here, so 0, that's a choice, so we would pick that. This is a yes. I'll put a check next to it. 1 is included in the set because remember, this means less than or equal to, so 1 is a yes. And we would say no to the numbers 5, 8, 11, and 17, because those would all be to the right on the number line. And the solution to this has to be 1 or anything less than that. All right, so now let's take a look at number 3. Number 3, they give us the simple equation of 5h equals 40. Now, if we were going to go ahead and solve this, we would say to ourselves, what's the opposite of multiply a variable by 5, and it would be to divide by 5. This would all cancel out. We'd bring down the h, we'd bring down the equal sign, and 40 minus 5 would be 8. So this one, we know that h is equal to 8. But what if we have the same stuff, only instead of an equal sign, they give us this symbol, which is the greater than symbol. So let's replace this symbol with the symbol that you see here, which is the greater than symbol. All right, so this would read as h is greater than 8. So if we do a quick number line and think about 8 and think about numbers that are greater than 8, so if we go to the right and think of numbers that are greater, there might be like a 9, a 10, 11, etc. And if we think about numbers that are less, like a 7, like a 6, and we think about how would we graph this, we would use an open circle, and all the values have to be greater than 8. So that's going this way. And a little tip, as long as the variable's on the left, this is almost like an arrow pointing in the direction that you need to shade. Just a nice little shortcut, but that only works if the variable's on the left. All right, so if we take a look again at the numbers that are offered up here, they want to know which of these are solutions. So if we look and see 8 is offered, but we're not going to pick that because 8 is not greater than 8, so that's a no. And of course, any of the numbers that are lower than 8 are a no. So the numbers that are a yes in this case would be an 11, and then a 17, of course, would be even further right on the number line. I didn't have room to graph that. So for number 4, we're picking 11 and 17. All right, let's take a look at ones that have a fraction in it, such as number 5. Let's rewrite that. So we have a half y equals 5. Now, the inverse of this really means 1/2 times y. And what's the opposite of multiplying by a half, it's to divide by a half. And I just want to remind you that dividing by a half is the same thing as multiplying by the reciprocal, which is 2 over 1. So that's what we're going to do. We're going to multiply both sides by the reciprocal of 2, or 2 over 1, same thing. I could write this with a 2 over 1 because this is a whole number. We don't really need to do that. All right, so what happens to the left side of the equation? All of this all cancels out, and it equals 1. And if we multiply 1 times y, that would be equal to y. And then 5 times 2 would be 10. All right, but in this case, what if we change the equal sign to being this? So we would kind of do the same exact thing, only let's just replace it with this symbol, which is the less than or equal to symbol. And let's graph it. So if we graph this, and we take the number 10, and we think about numbers that might be greater than that, such as 11, 12, 13, etc. And if we think about numbers that would be less than that, things like 9, 8, etc. Now, if we were going to graph this, because we have the line underneath the symbol, that means less than or equal to. So that means 10 is included as a solution. So we would do a shade, and then shade to the left. Again, I like to think of this almost like an arrow tip pointing in the direction that you need to shade. That'll always work for you every time, as long as your variable is on the left, because if the variable is on the right, that won't work. All right, now when we think about what are solutions to this inequality, numbers like 9 and 5/10, numbers like 8, anything that's less, right? And also 10. 10 would be a solution because 10 is less than or equal to 10. So that would be considered a solution. All right, so let's take a look at numbers 7 and 8, and then we'll finish up with that. All right, so numbers 7 and 8, let's first explore how do you solve this equation, which is k minus 3 equals 20. And we would approach this by applying our inverse operation. So you ask yourself, what's happening to the variable? It's being subtracted by 3. What's the opposite of subtract by 3? It's to add 3, and we have to do that to both sides of the equation to keep it balanced. All of this cancels out. We'll bring down the k, bring down the equal sign, and this plus this would be 23. Right, so the solution to this is k equals 23. But what if it's an inequality? So everything's the same except we replace the equal sign with this symbol here, which is the greater than symbol, by the way. So let's erase the equal sign and slip in the inequality symbol. So greater than, greater than. Now, once you have inequalities, then it's always a good idea to graph the inequality. I always like to put the number that they're talking about right here in the middle of my number line. And then since we don't have the little equal sign thing underneath, then it's going to be an open circle because 23 is not included in the set. And again, I like to think of this as an arrow tip pointing in the direction that you need to shade. So we're going to be shading in this direction, which means that numbers like 24, 25, etc., those would all be part of the solution set, where numbers like 22, 21, anything to the left would not be solutions to this set. And 23 is not included. That's not a solution to this inequality. All right, so that's what the graph would look like. And if we had to pick a bunch of numbers that were in the solution set, we wouldn't pick 23, but anything greater than that would be okay, because this means k is greater than 23. So if you think about, let's pick something on the number line like this value right here, 25. If we had substitute that into the place of k and said, is 25 greater than 23? We would say yes. So it is a solution.